Hello, Math Study students. We're going to begin our Unit 3 with this 3.1 to 3.2 lesson. Unit 3 will be a lot of review of algebra and geometry. What will be new is just getting used to the IB, some different vocabulary, and maybe some different ways of questioning. So let's start by talking about lines. We're going to talk about their slopes and their equations. So first of all, you need to learn possibly a new term, and that is the term gradient. Okay, the gradient is also called the slope of a line, and you'll recall that a slope of a line is a ratio of the vertical change to the horizontal change as we travel from one point to another. So if we have a point A with coordinates x1, y1, and a point B with coordinates x2, y2, as we travel from A to B, the gradient or the slope will describe the steepness of that line, the steepness. Okay, you'll remember from your algebra courses that to find the slope of a line, we simply take the difference of y values over the difference of x values. Remember, it is a ratio. It's a ratio of the change in y's to the change in x's. So we might want to go ahead and write this another way. You could also find the slope is by taking y sub 1 minus y sub 2 over x sub 1 minus x sub 2. So as long as you're consistent from numerator to denominator, it doesn't matter in what order you subtract the x and the y values. Now, you'll remember that if there's no vertical change, okay, if the numerator of this ratio is 0, then that line would be a horizontal line, okay, and its slope would be 0. If there is no horizontal change, that means that the denominator of the ratio would be 0. That happens when we have a line that is vertical, and we would say that the slope in that case is undefined because we cannot have a ratio with a 0 in the denominator of the fraction. That division by 0 is undefined. So we say that a vertical line, there's just no ratio that can describe the slope of a vertical line, so we say the slope is undefined. So let's do some examples, starting with example A. So we're going to find the slope by taking the ratio of the difference of y values to the difference in x values. So you'll notice that I'm taking the second y value minus the first y value on top, and then the second x value minus the first x value on the bottom, but you could turn both of those around if you want to. And so our slope turns out to be 3. Okay, so we have a slope of 3. If we have a slope that is a positive number, we know that that is a line that tilts to the right. Now let's find the slope of letter B. So I'm going to take the difference in y's. I'm going to take the second y minus the first y on top, and then the second x minus the first x on the bottom, and I'll get negative 6 over 3, which is negative 2. If you have a line that has a negative slope, remember that would be a line that tilts to the left. Okay? Letter C, we're going to take difference in x's again, so 6 minus 6 on top. I took the second y value minus the first y value. Now I'm going to take the second x value minus the first x value. So that would be negative 1 minus 2. So I'm going to get 0 over negative 3, which of course is 0. So that is a line where there's no change vertically. So if there's no change vertically as you travel from one line to another, we're looking at a horizontal line. And then I bet you can predict what's going to happen in this next example. The second x minus the first x on top, and then 1 minus 1 on the bottom, gives us negative 7 over 0. So that is an undefined ratio. Division by 0 is undefined. So that means we're looking at a line that has no slope. So we'll say that the slope is undefined, and we will know that that would be the slope of a vertical line. So now let's practice graphing a line given a point that lies on the line, and if we're given the gradient or the slope. So what we'll do is we'll go ahead and graph that first point. Let's graph the point 1, 4. So from the origin, I'll go to the right 1 and up 4. So we'll graph that point, and then with that gradient of negative 1, we might write it as negative 1 over 1, which means from this point, we'll have a vertical change of negative 1 followed by a horizontal change of positive 1. So that means from this point we would go down 1 and to the right 1 to get another point on that line. And then we can do that again, but as you recall from your freshman geometry class, through any 2 points there exists exactly 1 line, so we only need 2 points to get that line. Let's look at example B. We'll start by graphing the point 0, negative 2. So from the origin, you won't go left or right at all, but we'll go down 2 and plot that point. Okay, and then we have a slope of 2/3, so that means from this point we're going to make a change vertically of 2, followed by a change horizontally of positive 3. So that means go up 2 and to the right 1, 2, 3 to get a second point, and then we'll draw a line through that point. Oops, I kind of missed. There we go. Now, when you're doing this on paper, I would recommend you use a ruler so you get a nice straight line. Now let's review the slopes or the gradients of parallel and perpendicular lines. So you might recall that lines are parallel if and only if they have the same slope or the same gradient. So if 2 lines are parallel, they're going to slope in the same direction, so they would have the same slope. Lines are perpendicular if and only if the product of their gradients or the product of their slopes is -1. Another way to state that would be the slopes would be opposite reciprocals of each other. If you have 2 numbers that are opposite reciprocals, when you multiply them, their product will be -1. All right, so let's look at this first example, and this is the style of questioning you need to get used to. Line L sub 1 passes through the point 0, -3, and through the point B, -7, 4. So the first thing we're going to do in letter A is we're going to find the gradient of the line that passes through those 2 points. So let's take 4 minus and -3. I'm going to write that as 4 plus 3 in the numerator, and then -7 minus 0 in the denominator. So that gives us 7 over -7, which is -1. So our line has a slope of -1, or a gradient of -1. Okay, now we're to draw and label L sub 1. So what we need to draw is a line that passes through these 2 points. So let's graph the point 0, -3, and then graph the point -7, 4. So 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3, 4. Okay, so let's graph that point. And then again, on your notes, you might want to grab a straight edge so you get a nice straight line. So we drew the line, and then let's label it with its name. Its name is L sub 1. So the name of that line is L sub 1. Okay? Then we're going to draw and label a line L sub 2 that passes through the origin and is parallel to L sub 1. So if it passes through the origin, we know, I'm going to do this line in a different color, we know that it passes through 0, 0. Now it's parallel. If it has a parallel, that means it is the same slope. Okay, so from this point, if we have a slope of 1, we could write that slope also as -1 over 1. So from this point, we're going to go down 1 and right 1 and get another point. Okay, and then if you have a straight edge, please use it and draw a line that passes through those 2 points, and we will label that line L sub 2. Now let's take a look at this next example. It says the diagram shows perpendicular lines L sub 1 and L sub 2. So we're first going to find the gradients of the 2 lines, and then we're going to kind of prove that they're perpendicular by showing that the product of their gradients is -1. So let's start with line L sub 1, and we'll pick a couple of what we call pretty points. So I'm going to pick the origin and the point 1, 2. Pretty points are just points that it's easy to read their coordinates. Okay, so as I travel from one point to another, my vertical change would be +2 and my horizontal change would be +1. So I'm going to write it like this. The slope of line L sub 1 is +2. Now let's find the slope of line L sub 2. So again, we'll pick a couple of pretty points, like I guess we could use the origin again, and then this point. So as I travel from one point to another, my vertical change would be +1 and my horizontal change would be -2. Remember, slope is determined by making a vertical change to a horizontal change. So I would go up 1 and left 2. So that means that slope is going to be +1 over -2, or we probably would just write that as -1/2. So we've finished letter A. We have found the slopes of the 2 lines. Now let's show that the product of their gradients is -1. So if I just take that +2 and multiply it by -1/2, we get -1. So we've kind of arithmetically proven that these two lines are perpendicular because we've shown that the product of their gradients is -1. Their slopes are opposite reciprocals of each other. So now let's focus our attention on writing the equations of lines. And we're first going to talk about writing equations of line in what we call gradient-intercept form of a linear equation. Now you're used to calling this slope-intercept form of a linear equation, but this is just a slightly different terminology. Also, we will write the equation y equals mx plus c. Now you're used to this constant being the variable b, but that's okay. We can use c for our constant. And let's identify those parts. Well, since it's slope or gradient intercept form, then m would be the gradient or the slope of the line, and then c would be the y-intercept, the y value of the point where the line crosses the where the line crosses the y-axis. So this first example says the line L passes through the point A with coordinates 1, 7 and has a gradient of 5. Find the equation of L in gradient intercept form. Okay, so our final answer is going to look like this, y equals mx plus c. But we're going to start by using point slope form. Notice we're given the point and the gradient of the slope, so that lends itself perfectly to point slope form, which you'll recall looks like this. Y minus y sub 1 equals the slope times x minus x sub 1. So we just need to replace x sub 1 and y sub 1 with the coordinates of a point that the line passes through, and then m with the gradient. And we're given all that information. So our equation would be y minus 7 equals the gradient of 5 times x minus 1. All right? So now to get it in this slope gradient intercept form, we just need to solve this equation for y. So let's start by distributing on the right side and getting rid of those parentheses. So we have y minus 7 equals 5x minus 5, and then add 7 to both sides, we get y equals 5x plus 2. So that is the equation of the line in gradient intercept form. The next example says the line L has gradient 1/3 and passes through the point A with coordinates 2, -1. So we're going to do all these steps. Let's start with letter A that says find the equation of L and give your answer in the form y equals mx plus c. So let's do what we did last time, and let's start. I'm going to work problem A over here. Let's start by putting the equation in point slope form or point gradient form, and then we will solve it for y to get it into slope or gradient intercept form. I'm used to calling it slope intercept form also. Okay, so we're going to start by first of all replacing x1 and y1 with these coordinates, and then we will replace the slope or the gradient with 1/3. So let's rewrite that equation. It would be y minus a -1. I'm just going to write that as +1 because subtracting a -1 is the same thing as adding 1. So that's equal to our slope of 1/3 times x minus the x value of the point, which is 2. So now we just need to solve that for y to get it into the right form. So I'm going to, on the right side, I'm going to distribute and get rid of those parentheses. So that would be 1/3 x minus 2/3, okay? And then to solve for y, I need to subtract 1 from both sides, but why don't I write that over here? I'm going to write it as 3/3 since I need to subtract it from 2/3. So our final answer would be y equals 1/3 x. And then, let's see, -2/3 minus 3/3 more would give me -5/3. So minus 5/3. Okay, so that's our answer to part A. Now let's look at part B that says, write down the point of intersection of L with the y-axis. In other words, we're going to find the y-intercept. So for part B, our equation is y equals 1/3 x minus 5/3. So the y-intercept is going to be the point where x is equal to 0. So just replace x with 0, and then we'll do the arithmetic. 1/3 times 0 is 0, and 0 minus 5/3 would be -5/3. Okay, now look carefully at the question, make sure you answer it correctly. It says write down the point of intersection. So we have found the y value when our x is equal to 0. So our final answer is going to be the point 0, 5/3. All right, so make sure you answer in the form it's asked. Okay, part C says now we're going to find the point of intersection of L with the x-axis. So we're going to say take the same equation, but the line intercepts the x-axis where y is equal to 0. So this time we're going to put a 0 in for y, and we get 0 equals 1/3 x minus 5/3. And now we just need to solve that for x. So I'm going to add 5/3 to both sides. Okay, and then since x is being multiplied by 1/3, I would undo that by dividing by 1/3. Well, that's the same thing as multiplying by 3. So let's multiply both sides of the equation by 3. So I'm going to write it in a different color. And we'll end up with x being equal, let's see, these 3's cancel, okay? So we get x is equal to 5, and then again, the problem said find the point of intersection. So we have found the x value. We have found the x value when y is equal to 0, so the coordinates at that point would be 5, 0. Okay? And then letter D says, draw a line L showing clearly the information we found in B and C. All right? So we're just gonna, for letter D, let's just set up some axes. And I need to, let's see, I need to intersect the x-axis at the point 5, 0, and the y-axis at the point negative 5/3. This is negative 1 2/3. So I'm going to call this negative 1 and this negative 2, and then 1, 2, 3, 4, 5. Let's go ahead and put some numbers here so we have a scale on our axes. All right, and so I have one intercept. The y-intercept is at 0, negative 5/3. So it's hard to tell, but I'm trying to draw where I'm 2/3 of the way between negative 1 and negative 2. And then the other intercept, the x-intercept, is at 5, 0. So clearly show those 2 points, and then just draw the line that passes through those 2 points. So now let's take a look at this next example. It says line L joins points A and B. Find the equation of L, and this time we're going to give our answer in what's called general form. AX plus BY plus C equals 0. Basically, all you need to know about general form, you don't need to memorize it, it'll be in the formula book, but we just need coefficients of x and y and our constant term to all be integers, and we need one side equal to 0. So I'm going to show you a couple different ways to do this, and you can pick which way you like the best. So I'm going to start by putting the equation in point-slope form, which means I need a slope. So to find the slope, I'm going to take the difference of y's in the numerator and the difference of x's in the denominator and get negative 3/4, okay? And now I'm going to plug into point-slope form. So let me write that form down again. It's y minus y sub 1 equals the slope times x minus x sub 1, okay? So in x1, y1, I'm going to put the coordinates of either of these points. I think I'll pick the second one because it has all positive coordinates. You can use either point. And then for the slope, I'm going to put in this negative 3/4. All right, so our equation would look like this. Y minus 2, that's the y value of the point, equals the slope of negative 3/4 times x minus the x value of our point, okay? Now to get it into this general form, let's start by getting rid of these parentheses. So I would have y minus 2 equals negative 3/4 x plus 3/4. When I take negative 3/4 times negative 1, I'm going to get a positive 3/4. Now, remember, A, B, and C all have to be integers. So let's take care of the fact that I've got fractions here by just multiplying through by a least common denominator, which of course would be 4. So I'm going to multiply both sides by 4, and that'll get rid of those fractions for me. So on the left, we would have 4y minus 8 equals, on the right, we'd have, let's see, negative 3/4 times 4 would give me negative x, okay? I mean negative 3x. Basically, the x's are just going to cancel. Okay, let me erase that. Okay, negative 3x. Okay, so when we take negative 3/4 times 4, the 4's will cancel. I get negative 3x. And then plus 3/4 times 4 gives us 3. So we've taken care of making sure that a, b, and c are all integers. Now, to get it in this form, I just need one side equal to 0. So let's add 3x to both sides and also subtract 3. I'm going to do that all in one step. I hope I don't lose anybody. Then we'll get 3x plus 4y, because I added 3x to both sides. Now I'm going to add 3 to both sides, so that would be minus 5 equals 0. Okay, so... Okay, let me fix that. You probably caught that mistake. When I subtract 3 from both sides, negative 8 minus 3 more will give me negative 11 equals 0. There we go. Now we have the equation in general form, okay? So that's one way you could work it. Let me show you another way that you might like better that would be quicker. Remember, we get the slope by taking difference in y's over difference in x's. So let's just pick one of our points. Let's just pick this one, and let's write kind of a generic version where we say y minus 5 over x minus a negative 3, which would be x plus 3, gives us the slope. Remember, slope is difference in y's over difference in x's. So if we let xy be any point on the line, then the y value of any point minus 5 over the x value of any point minus negative 3 or plus 3 gives us the slope of negative 3/4. So that gives us a slope of negative 3/4. Remember, we already found that slope earlier. Now from here, we could cross multiply. This is a proportion, and we can cross multiply. When we do, we would get, let's see, we would get, when I cross multiply this way, I'm going to take 4 times y and 4 times negative 5. So that's going to be 4y minus 20 equals, now I'm going to take negative 3 times x, which would give me negative 3x. And then we're going to take negative 3 times positive 3, which would give me minus 9. So now all we need to do is move terms around so we make it put it in general form. So we need one side equal to 0. So I'm going to add the 3x to both sides and add 9 to both sides. And that would give us 3x plus 4y minus 11 equals 0. I just added 3x, and then I added 9 to negative 20. And you see we get the same equation as we did here. So that's a little shorter way if you'd rather do it that way. Okay, so letter B then says the point Q with coordinates 5/3 t lies on line L. Let's find the value of t. So let's start with our equation, which is 3x plus 4y minus 11 equals 0. Now, let's go ahead and put 5/3 in for x, and then let's see what the y value is. Notice that we have the variable t here, but that's the same as y. So I'm going to rewrite my equation, but where I see an x, I'm going to replace it with, 5/3. So 3 times 5/3 plus 4 times, let's go ahead and just change that y to t so it doesn't confuse you, equals 0. 3 times 5/3 is 5, so we have 5 plus 4t minus 11 equals 0. So now we just need to solve this equation for t. I'm going to start by combining like terms. So I have 4t minus 6 equals 0. Then we'll add 6 to both sides. 4t is equal to 6, and then when I divide by 4, we'll get that t is equal to 6/4, or you could reduce that to 3/2. Now let's finish up with a couple of review items that you've probably studied before. Let's first of all talk about horizontal and vertical lines. The equation of any horizontal line will always be y equals k, where of course k is a constant, and any vertical line is going to be x equals k, again where k is a constant. I don't know if I've ever showed you this little mnemonic device before, but if you write down HOY and VUX, that's a great way to remember equations of horizontal and vertical lines. The H stands for horizontal. This is the letter O, but it reminds you of a 0. That will remind you that a horizontal line has a slope of 0, And the y reminds you that the equation of a horizontal line will be y equals k, okay? In VUX, V stands for vertical. Vertical lines have undefined slopes. That's what the U is for. And then the X reminds you that the equation of a vertical line will always be X equals a constant. So that's a little trick that might help you remember slopes and equations of horizontal and vertical lines. Okay, so let's finish up then with systems of linear equations. So you'll recall from your earlier classes that if L1 and L2 are coplanar, then either they're going to coincide, which means they are actually the same line, one line on top of the other. They are parallel, which means they would never intersect, they'd never have any point in common, or they intersect. And you'll recall from geometry that if they intersect, they're only going to intersect once. So let's try this example where we're going to find the point of intersection of the lines y equals 2x plus 1, and then negative x minus y plus 4 equals 0. So we have one line that's in gradient intercept form and one line that's in general form. So let's go ahead and solve there. And there's different ways to do this. I think the quickest way will be just to use substitution. So I'm going to rewrite this equation. I'm just going to solve this equation for y. So that would mean just adding y to both sides. If I add y to both sides, I would just get y equals the opposite of x plus 4. So now what I'm going to do is go to my other equation where I see a y. I'm going to replace it with what y is equal to. So in other words, I'm going to replace this y with the opposite of x plus 4. So let's do that. We'll take the opposite of x plus 4 is equal to 2x plus 1. And then let's just solve this equation for x. So I'm going to, I guess we could subtract 2x from both sides. And we would get negative 3x plus 4 equals 1. Now let's subtract 4 from both sides. We get negative 3x is equal to negative 3. So x is equal to 1. All right, so now that I know what x is, I can take that x, that's 1, and I can plug it into any of these equations. Let's just put it in right here, and then we'll be able to find the y value. So y equals 2 times 1 plus 1. Again, I'm just rewriting this equation, except where I see an x, I'm putting a 1 in. So y would be 2 plus 1. Y would be equal to 3. So now the direction said find the point of intersection of the two lines. The x value of that point is 1. The y value of that point is 3. So let's write our answer as an ordered pair, and we'll write it 1, 3, and that's the point of intersection. All right, so you'll be doing some practice problems in class. So if you have any questions, be sure and let me know.